The internet is about to change forever. A revolutionary technology, the quantum internet, has just launched, and it promises something unheard of: unhackable communication. If true, this could mean the end of cybercrime as we know it. But how does it work? And is it really as secure as they claim? Let's dive deep into the future of the internet. Welcome to Atomic Domain, the place where science meets the future. The AI revolution, quantum breakthroughs, and space exploration are reshaping the world, and you don't want to be left behind. If you're fascinated by cutting-edge technology, hit that subscribe button and join us as we unravel the mysteries of the universe. Now, let's explore the quantum internet, one of the most mind-blowing advancements of our time. The internet we use today is built on classical computing principles: binary code, data packets, and encryption methods that rely on mathematical complexity. But there's a fatal flaw: everything digital can eventually be hacked, no matter how advanced encryption becomes. With enough computing power, it can be cracked. And here's where the quantum internet changes everything. What is the quantum internet? Unlike traditional networks, which transmit information as electrical signals or light pulses, a quantum internet transmits data using quantum entanglement and superposition. Instead of relying on classical bits 0 south and 1 south, it uses qubits, quantum bits, that can exist in multiple states simultaneously. One of the core principles behind this technology is quantum entanglement, a phenomenon where two particles become interconnected, meaning that changing the state of one instantly affects the other, no matter how far apart they are. This allows instantaneous, ultra-secure communication, since any attempt to eavesdrop would immediately alter the quantum state, making detection unavoidable. How does the quantum internet work? The backbone of the quantum internet relies on quantum key distribution, QKD. QKD ensures absolute security by using quantum mechanics to encrypt and transmit keys between parties. If a hacker tries to intercept the transmission, the quantum state of the data changes, instantly alerting the system to the intrusion. Here's how it plays out in real-world use. Alice and Bob want to communicate securely. They exchange a cryptographic key using quantum entanglement. If anyone tries to intercept the key, the quantum state is altered, and Alice and Bob immediately know something is wrong. Since an intercepted key is useless, hackers are completely locked out. Advanced concepts of the quantum internet. The quantum internet isn't just about secure communication. It introduces several groundbreaking capabilities. Quantum repeater networks, unlike classical internet infrastructure that uses routers and repeaters to boost signals over long distances, quantum repeaters preserve entanglement across vast networks, enabling truly global quantum communication. Quantum memory storage. Future quantum networks may utilize quantum memory devices capable of storing and retrieving entangled particles, drastically improving efficiency and security. Quantum cloud computing. Users could perform computations on remote quantum servers while ensuring absolute privacy, as the quantum internet ensures that no external party, even the computing service itself, can eavesdrop on the data being processed. Why is this revolutionary? Unhackable communication. The biggest advantage is that quantum encrypted messages cannot be intercepted without detection. Unlike traditional encryption, which can eventually be cracked, quantum encryption is theoretically impossible to break. Faster and more efficient data transfer. Quantum teleportation using entanglement to transmit information instantaneously could make communication speeds faster than anything possible today. Eliminates the threat of quantum computers breaking encryption. Classical encryption methods like RSA and AES will become obsolete when quantum computers become powerful enough to break them. The quantum internet solves this problem before it even begins. Is the quantum internet already here? Yes, at least in experimental form. Scientists have successfully demonstrated small-scale quantum networks in China, the US, and Europe. China's Misha satellite was the first to achieve quantum communication between space and Earth, proving that quantum secure data transmission is possible over long distances. Meanwhile, researchers at MIT, Harvard, and the University of Chicago are working on quantum repeater networks to expand the quantum internet's reach. Quantum communication experiments are also underway at Google, IBM, and European quantum research labs. The major challenge now is to scale the technology from small networks to a full-fledged quantum internet infrastructure that can support millions of users worldwide. When will we see a full quantum internet? Building a fully functional quantum internet at a global scale is still a decade away, but the foundations are already in place. Companies like Google, IBM, and China's Baidu are investing billions into quantum networking technology. Within 10 to 15 years, a functional quantum internet could be available for military, financial, and government communications before eventually reaching the public. Potential risks and ethical concerns. With any groundbreaking technology, there are risks. While the quantum internet promises unhackable security, it also raises concerns. Who controls the quantum internet? If it is monopolized by governments or corporations, will the public truly benefit? Could it create an even bigger digital divide? If only wealthy nations have access, will the rest of the world fall behind in cybersecurity? What happens to current encryption systems? Banks, intelligence agencies, and tech companies will need to overhaul their entire security infrastructure to keep up with the shift. Can quantum systems be manipulated? While QKD theoretically prevents hacking, advancements in quantum technology produce new forms of cyber threats that we haven't even imagined yet. The future of cybersecurity and the internet. The launch of the quantum internet marks the beginning of a new technological era, one where hacking, cyber warfare, and data breaches could become obsolete. But like all disruptive technologies, its real-world impact depends on how it's developed, who controls it, and how widely it is adopted. Imagine a world where every financial transaction is unhackable, where medical records are transmitted with absolute security, and where global communication is faster and more efficient than ever before. That future is no longer science fiction, it's on the horizon. The future is unfolding before our eyes. Will the quantum internet bring an era of absolute security? Or will new threats emerge that we haven't even imagined yet? Let's discuss. Drop your thoughts in the comments. Hit that like button and subscribe to Atomic Domain to stay ahead of the latest science and tech revolutions. The internet is evolving, make sure you evolve with it. The age of quantum technology is here. Are you ready?